Our second presenter speaker is Dr. Adrian Song, and he's founder and CEO of LEADUS, and he's also former research fellow at Hong Kong Polytechnic University, specializing in vacuum insect glazing and green building. And since commercialization in 2019, LEADUS has attracted prominent investors from Hong Kong and Silicon Valley, and they have headquarters at the Hong Kong Science Park. And today he will present about the production of VIG and achievements on that.
Okay, thank you.
Welcome.
So thank you. Good afternoon. I'm Adrian from LEADUS. And before coming to GPD, I was told that the GPD is a professional conference. So I want to share something technical in terms of innovative vacuum insulated glass technology about the process and the material of how we produce the reliable vacuum insulated glass. So since the first VIG was born in Sydney University, it is widely known that VIG can provide a very good thermal insulation and it can block the most of low and medium frequent noise. So our vision is to insulate and silence your world with VIG produced by our technology solutions. About structure of a VIG, so we have edge seal on both sides of glass with the use of the metal sealing. We have the pillar array placed on the surface of the clear glass. And in order to hide the getter into the window frame, so we designed the needle getter. So about the vacuum layer, there's only 0.1 to 0.2 millimeters in thickness, includes the thickness of the both sides of the glass. There are only about 6-8 millimeters thickness in total. Here is the coefficient of the pressure, which is the vacuum level, and the U value, the coefficient between them. This line graph shows that if you see this line over there, that's the total U value here. And the line below is the center when you're testing the center of the pen. So from this line, you can see once the pressure, the vacuum level, arrive at 10-1, there are no significant change for the U value. So which means it's the inside vacuum level of the glass vacuum layer. It's kind of from 10-1 to 10-3 Pascal. About advantages of the vacuum glass. So three main advantages. So 60% reduction in solar heat gain and more than 45% reduction in winter heat loss. And it can block noise of the low to medium frequency noise, up to 40 dB. So after talk about so many advantages of VIG, it sounds like there are many advantages, but why VIG is still rare in this market? The reason is the technical challenges. So these pictures list several products that need vacuum sealing. So before I start to share with you an idea and definition, so there's no 100% perfect vacuum sealing. So in other words, every sealing have a certain leakage. If you look at like LED lighting, photovoltaic modules, the vacuum level is kind of low. But when we talk about VIG, so it has same leakage rate requirement for its sealing. So the requirement for VIG has a meter requirement basis, whereas the nano devices and processing chip are much smaller than that. So to be brief, the technical challenge is the same leakage rate, but much larger and more diverse. So I'll give you an example of the daily order we took from our client. So like 50 square meters order are usually contains more than 100 different sizes of VIG. That's the challenge to mass produce VIG. About evolution of a VIG, here I list three different structures. So let's start from material. Basically, there are two different material applied in industry. One is glass frame. The second is metal. And about process, there are also two main different process. One is sealing at first and then encapsulate later. And the other is what we use is we encapsulate in vacuum. We're sealing the VIG in the vacuum furnace. So result quality of the product because the melting temperature of the glass fluid, which commonly used for produce VIG, the melting temperature are usually higher than 450 degrees. So it will result in annealing of the glass. I don't want to say all of them, but most of the glass fluid products, they can only produce float or annealing VIG. But as we all know that for the most of the area and region in the world, it seems tempered glass are more widely accepted. So talk about the process sealing first and encapsulation later. So there are the generations of VIG. They have pump out pipe, very visible, pump out air from that pipe. In order to protect the very tiny, thin pipe, they have to put a cover on top of it. Because existence of the protect cover, so it's very difficult to further process the glass. It's very difficult to you're doing the hybrid with lamination, hybrid with IGU. So for the next generation of VIG, no matter what kind of material they use, but they all develop to a cap, flat cap. There are pump out pot to pump out from the very small pot. So that makes the VIG takes at least more than 6 to 8 hours. So that's totally impossible to mass produce VIG. In order to resolve these problems, we develop technology and process is we capsulate in vacuum. So which means we sealing in the environment, vacuum environment at the same time. We can reduce the production time within 15 to 20 minutes, depends on different thickness of your glass. Here's the reason that why we choose metal as a sealing material. So before I start with it, let me interpret about what is the probability. So probability is the ability that the material allows the gas and the liquid through it. So that means the lower probability, in other words, lower leak rate, will bring a longer span of the product. For a VIG, at least have to make it used at least yearly base. No even to mention that 15 or 20 even longer. So at least year based. So that seems like there are only 3 options: glasses, glass fluid, metal sealing, material, pure crystals. So although there is another option, but the reason that nobody choose pure crystal is because I'll give you an example. So the salt we ate every day is a kind of pure crystal. It's very difficult to be processed, not like glass and metals. So that's the reason there are only 2 options. But why we choose metal, not glass fluid? Because there are 2 considerations of us. One is metal can provide higher strength and flexibility. The glass fluid, when I took PhD in Hong Kong, we test all sorts of materials, and we found that the glass fluid is kind of brittle, and any micro cracks can compromise the vacuum over time. And we talk about manufacturing and the product because the melting temperature of the metal is lower than 250 degrees. So it will totally not destroy the temperature level of the glass. Also, glass fluid has the similar thermal expansion, but it may cause annealing because of the higher temperature, melting temperature. About the mechanical strength tests, we conduct testing in China of building research. So we use 2 rolls bottom to support the glass, and another 2 roll on top of it, and we put a pressure on top of it. And then what we find? So the extreme bending strength of the glass, we find that if you use a metal sealing, is over 200 megapascal, but glass solder is about 180. So that is the public data you can check from the website. So to shortly conclude here, so higher strength, better mechanical is the main reason that we choose metal as our sealing material. If we want to be more academic, here are several pictures. The top view of our product, which we display over there, we have a alloy ceiling around the edge, and then here are the float glass. And here is the cross-sectional views. So if you see our structure, so we have both glasses and metallization on each glass. So the picture is, if you want to sealing something, you have to make it have a similar thermal expansion. So in order to solve that, so we have metallization layer. On side, it has similar expansion with glass. On that side, it has a similar expansion with metal, with the alloy we use on both sides. Again, lower permeability, higher strength. So about the material and the process, so basically we have three main material to produce our VIG. So the first is the ceramic pillar we use. We don't metal pillar. To be honest, we previously we used the metal pillar. We tried the metal ball, we tried the cylinder pillars, but we found if you want to mass produce a VIG, use the ceramic pillar will be much faster, very obvious cost-effective advantages. And then we dispense the paste. We dispense paste like that around the edge of the glass, on both sides of glass. And next step, we clay the alloy. The alloy is the solder, the wire on top of the metal layer, but the metallization layer. In the end, before we put it into the vacuum furnace, we booked both sides together. So in order to have a better understanding of our technology solutions for the coming slides, I put some videos on it. So the videos left side is the whole process of our VIG. So we use Glaston temper furnace. So we automatically deploy our pillars, and then you see here we use a 3D measure method to dispense metallization paste and then put it into the vacuum furnace. So I have to mention here that the flatness of the tempered glass is very important. If it's not flat enough, it's very difficult to book them together, and it will cause a failure in the end. So we have a couple of cases and experience of production line. So the prototype line, which is actually it's not a line, it's just a vacuum box. It can only produce the 300 by 300 sample in 2017. This line is, we call this first line. The size is 1 meter by 1.5 meter. We have it in 2018, but actually we don't use it anymore because this line is quite slow and quite small for us. And then we have three before we officially provide our production line technology to our client. We have experienced 2 production line in our factory. And in fact, 2 of them, line 3 and line 4, are still in operation in our factory in Hebei. So you are very welcome to visit our factory. Here are our demo project. The VIG produced by ourselves with the use of LEADUS vacuum insulated LEADUS production line. The first demo project, I would say, is located in Dayton, Ohio, United States. We supply about more than 4,000 square meters VIG. The property owner chose VIG is because he used VIG. He doesn't need to replace the existing window frame. And this is actually a refrigerated project. And we have the property owner saved more than 60% of budget, save the construction period as well. I thought there will be a voice, but it's okay. Here are the orders we produce for our client and ship to Europe. Again, for the previous picture, you can see the edge, the yellow edge can completely be hidden by the no matter frame or glue. So this project is actually somewhere in Netherlands. This also a retrofit project. It is Regent Hotel is the historical buildings in Hong Kong, and with more than 50 years old, I would say. So, and that is the second time of renovation. So, if you see this video over there, the property owner apply our VIG on the lobby. On the second floor are still the lamination glass. You can see the condensation are very obvious. But in the first floor, it's very clear, no condensation at all. This project, we are granted by the VIG Retrofit Green Project Award in Hong Kong. And that is the largest VIG. I'm not sure if it is still largest VIG in the world, but I'm sure that by that time, that is the largest VIG produced in the world, which is over the size is over 2 meters by 3 meters. That is the new building in Beijing. The first zero carbon hotel project, which is called Beijing Zilong Hotel. And we had an interview by Beijing TV. So this project, we provide VIG together with 65 millimeters wide window frame. So the window system U value is only 0.8 around that. It's definitely the passive house standards. So because there are more than 20,000 glass processors in the world and can totally produce more than 1 billion square meters of all sort of glass. But in this sector, there are definitely less than 10 VIG factories producers and can totally produce VIG within 200,000 square meter per year. So what does our industry need? We need somebody can help with building more VIG factory, help more factory scale up the production of VIG. So we set this as our mission. About LEADUS, our company. So I graduated from Hong Kong Polytechnic University. After I graduate, I got funded by Hong Kong and set up this company. We have our own factory located in Middle China in Hebei City. And we have another JV factory in Foshan. And this factory is actually our first client. And their production has already in operation. Yeah, because I'm already running out of time. So any questions are welcomed. Thank you. Thanks for your attention.